In today's lesson, we're going to talk about angle relationships with transversals, specifically looking at parallel lines cut by a transversal. So this transversal, all it means, its definition is it's going to be a line that cuts through two or more lines. So a line that cuts through two or more lines. So the transversal in this image here would be line N because it passes through two or more. And specifically in this case, if we read what we're given, if two parallel lines are cut by a transversal, well, the parallel lines here are going to be L and M. Those are going to be our parallel lines cut by that orange transversal of N. When this occurs, we're going to have the following five kind of circumstances down here. So let's take a look at our first one, which is going to be if two parallel lines are cut by a transversal, then alternate interior angles are going to be congruent. So when we talk about alternate interior, we're going to take a look at our transversal here. So this is kind of like an image brought down from above, just so we can look at the alternate interior here. Well, first and foremost, alternate means opposite sides of that transversal. Interior means it's between those blue parallel lines. So I'll highlight that in yellow. It's kind of like it's sandwiched in between. An example of alternate interior here would be 4, kind of in our image, and then 5. And then same thing, 3 and 8. You kind of have to have one along each of those parallel lines. So just showing you in our image, 4 and 5, and then 3 and 8. The next relationship we have is if two parallel lines are cut by a transversal, then alternate exterior angles are congruent. So when we talk about alternate, again, they're on opposite sides of that transversal. So one would be on the left, one would be on the right. And then they're going to be outside of our parallel lines instead of interior. So that's going to be the yellow I'm shading outside those parallel lines in this case. So it's going to end up being the following. If you take a look, it's going to be the top right, and then go on the opposite and exterior along that second parallel line is going to be the alternate exterior angle. Then same thing, if I take the green in the top left, I have to do the alternate and exterior along that second parallel line to make it alternate and exterior. And I'm going to go ahead and label those in my diagram up here with my O's and my X pinks. So it's really cool if you take a look, just a brief moment, at our top diagram as we have those X's and O's. And it's going to be cool because the X is going to be the same number, and the green O's are going to be the same number, but a different kind of number usually. Unless they're both 90. But it's usually a different number, again, unless they're 90. So it's going to make that really cool pattern kind of each time we go along with these parallel lines. With our next angle relationship, we're going to have if two parallel lines are cut by a transversal, then corresponding angles are going to be congruent. And remember when we talk about congruent, it just means they're going to be that same number, that same angle measure in degree. Corresponding is going to be in matching positions along those parallel lines. So we'll talk about that in a second, but think about matching positions for corresponding angles. We have our orange transversal and we have our blue parallel lines here. Okay, so we're going to take this top left angle, for example. It's on the left side of the transversal and it's on top of my first parallel line of L. I'm going to go ahead and copy that same position to the intersection of the transversal and parallel line M below. That's going to be corresponding angles because they're the same in matching position. Same thing, bottom right, bottom right here. That same kind of intersection. Same thing, 2 and 5, if you look at our picture above, are kind of highlighting in our image next to us above the line on the right for the first parallel line of L. Copy that same intersection pattern down here for line M. And then below the parallel line in the bottom left of our intersection up top, number 4, would go with number 7 down on the bottom left of parallel line M. So it makes that kind of pattern again for our corresponding angles. But again, if you look back up at our picture, corresponding angles would be 1 and 8, 4 and 7, 2 and 5, and 3 and 6. Now, 2 more. If 2 parallel lines are cut by a transversal, then consecutive, which just means same side, interior angles are going to be supplementary. So we now have a different word than congruent. They're going to be supplementary in this case. And all you need to know is that they're going to add up to 180. Supplementary, like we remember before, means they add up to 180. So let's talk about what those look like. So again, I have my orange transversal, then my blue parallel lines, and I'm talking about consecutive interior. So I want to focus on that yellow kind of sandwich between my 2 blue parallel lines there. Same side means they're on the same side of that transversal. So interior will be this top one, and then the bottom one on that same left side, and then again, the bottom one and the top one on that same right side, both in the interior. So that's kind of color-coded what they look like. If you look back at our image up top, examples of consecutive interior would be 4 and 8, and then 3 and 5. Last but not least, if 2 parallel lines are cut by a transversal, then the consecutive, again meaning same side exterior angles, are going to be supplementary as well. So really think about if they're consecutive, if they're on the same side, you're really looking at them being supplementary, adding to 180. So let's take a look here. I got my orange transversal. I got my blue parallel lines. And I'm looking in the exterior same side here. So highlight the exterior outside, not sandwiched between my parallel lines. So that means the top right would be same side exterior with this bottom right side here. So that would be 2 and 6 being same side exterior in our top diagram. And then another example would be 7 and 1 in that top diagram. Let me use the right colors. 7 and 1 in that top diagram because they're on that same left side of their transversal in the exterior. And because they are different colors, they will be supplementary on that kind of right side here, the consecutive exterior and interior. So let's go ahead and use all this vocab for our first example here, which is going to be given line L and M are parallel, so let's highlight those parallel. Find the measures of the remaining angles if the measure of angle 1 is 120. So right away, let's fill this in here with 120. That's going to be our measure of angle 1 there. And we're going to make this angle 1 our green O, kind of making that pattern. So right away, I know angle 3 is going to be 120 as well because it is vertical to that 1. So right away, that same intersection, I got 120, and then I can copy and paste that pattern down here because of those corresponding angles. So I have 120, 120. So it's really cool. You can use your O's and color code, but anytime I have an O, it's going to be 120 degrees for my angle. Now the rest are going to be my X's, that kind of pattern we've been going through. And I'm going to make them pink because I like to color code, but pink X's in the following angles. Those aren't going to be 120, but they are going to be supplementary to that 120. We know for many reasons, but going back to kind of our roots, supplementary here is a linear pair. 1 and 2 are a linear pair, making that straight line of 180. So to solve and find for x, I do 180 minus that 120 to get 60. They're going to be supplementary there. So every time I have an x, I'll go ahead and label, I have 60 degrees. That's going to be my answers here. So if you want to go ahead and kind of write them out, we'll do that real quick. The measure of angle 1 is going to be 120. The vertical angle of 3 is going to be 120 as well. Compared to 1, the measure of angle 8 is a corresponding angle that's in the same side, the same left side of that orange transversal, and matching positions, the top left of the intersections both times. That's why that one's 120. And for 6, that's going to be compared to angle 1, alternate exterior, which we know are congruent. Awesome. So then, writing it down again, the measure of angle 2 is going to be 60 because it was a linear pair with that measure of angle 1. We're also going to have 4 as 60 degrees as well because 4 is vertical to that original angle 2 of 60 degrees. The measure of angle 5 is going to be 60 as well because it is corresponding to angle 2. They're on the same right side of that transversal and matching positions, the top right of each intersection along those parallel lines. And then the measure of angle 7 is going to be 60 degrees as well. That is vertical to angle 5 and alternate exterior to angle 2. For example 2, we're given that A is parallel to B. So here's my line A, which is parallel to line B. And then the other line that passes through both of them is going to be that transversal, highlighted there in orange. So I'm going to look and find the value of x and y. Well, I am given this 135 over here, this 135. I'll circle that one. And that's going to help me find out the rest. To find out x, I go ahead and see the relationship between the 135 and the x. Well, they're on the same right side of that transversal, and they're in matching positions, so they're going to be corresponding, which we know are congruent. So they will get the same symbol, and I can conclude that x is going to be my 135 degrees there. Now, because I know about vertical angles, I'll also put my circles in these positions because they're vertical to each other and in that same matching top left position. And then everywhere else, I'll have those kind of pink X's to make our X's and O's patterns like we've been talking about. So my Y over here is the same color green as that 135. And it's vertical to that 135, so it is going to be congruent. So both y and x in this case were 135. Let's move on to the next example, example number 3 here. We were given, again, A and B were parallel, so let's highlight those parallel lines in blue. A and B there. And then the line that passes through both of them is going to be that transversal in orange. Awesome. So I want to go ahead and solve for x, y, and z. Well, first and foremost, I was given here this 25. I was given that measure of 25 there. Now I can go ahead and go vertical with that 25 with an O, and then I can copy that matching position. It was in the bottom right corner, so my bottom right corner here will have a green O. And then same thing with the Z, I'll copy it on my second parallel line along that transversal. It's on the top left. So anything highlighted in green is going to be 25. So right away, I kind of went backwards, but Z is going to be 25 degrees, and so would be my Y. Now I have to go ahead and solve for X, which is going to be one of my pink X's. That makes our X and O pattern like we keep talking about. So now, to find that pink value, I use the 25 with this X, knowing that they are consecutive interior. They're on the same side of that transversal. They're on the bottom of that orange line. And in the interior, if I were to highlight the interior here, it's sandwiched right between these lines in yellow here. So they're same side because they're on the bottom of the orange transversal. Same side interior, we know are supplementary. So I do 180 because that's what supplementary has to equal up to, and I subtract the 25 that I know. That's because whatever is left for the X is when I subtract 25 from 180, because then I can add the 25 back to get to 180. So this comes out to be 155 degrees. So my X in this case is going to be 155 degrees. That's our example 3. We have 2 more examples, kind of adding some expressions, which is a preview to next time, but let's go ahead and try it. So we again have our parallel lines A and B. I'll highlight those in blue. Our transversal is the line that passes through 2 or more lines. So this orange one here. And then I can go ahead and make my X and O pattern. So again, my O's are going to be, I'll start with the 20. So everything vertical to that would be 20 as well in green, that green O. And then I can copy those matching positions. That was the bottom left, copy it to the second kind of parallel line, and same thing, top right, I'll copy it up. Everything else, because I only have one transversal here, is going to be that pink X. So my O's will be 20, my X's will have to solve for. So when I'm looking at this X plus 4, I want to go ahead and solve for X. That's what the problem's asking for, so I know I have to include that X plus 4. But it's pink. I don't know what my pink angle is, but I do know the same side exterior because it's on the top of my orange line, and on the exterior because it's not going to be sandwiched in between in the yellow here. Same side exterior are going to be supplementary. Plus, I know from my X's and O's that they are not the same number. They're going to be supplementary of each other. So that's how I set up this equation. I'll tell you where I got it from. I got this X plus 4 here in pink, my pink X. One of my O's was green, that same side exterior. Therefore, same side exterior, we're using that kind of vocab term and using what I know. And because one was a pink X and one was a green O, so they do not equal each other, they are going to be that supplementary. Then I go ahead and solve this simple equation. Keep the X where it is, but since 4 and 20 are on the same side, I combine like terms. 4 plus 20 gets me 24. Keep that equals to 180 for now. To get X all by itself, it's X plus 24. So I have to do the opposite, which is subtract. X is just left on that left side. And on my right side, the only thing that's left is 180 minus 24, which is going to be 156. So X in this case will be that 156. That's the value of X for example number 4. Last example, example number 5. Again, we're given A and B are parallel. So let's go ahead and highlight those in blue. Those are my parallel lines. My transversal is the line that passes through both of them. This orange one here. Then I can go ahead one last time because it's our last example for the notes and go ahead and start with the 30 I know with an O, go vertical to that with another O, then copy that same matching position, those corresponding angles. Do the same thing with my pink X's, go vertical here, and then vertical here as well. So what I need to solve for here is the value of X, and I locate that in my diagram, which is going to be in this bottom right there. Value of X is in this bottom right here. Well, the only other number I was given was this 30 up here in the top left. But good news is because they are both green O's and they're also in alternate exterior positions, which we know are congruent. So I can equal 3x to 30 because both of those are green. So I'll kind of highlight underneath so that way you see where I'm coming from. Since they're both green O's and they're alternate exterior angles, meaning they're on opposite sides, the 30 is on the top of the orange transversal and the 3x is on the bottom of the orange transversal. And they're in the exterior because, again, they're not sandwiched in between those blue parallel lines in the yellow. They are congruent. I go ahead and solve this one-step equation. It's 3 times x, so I have to do the opposite, which is divide 3 away from the x. 30 divided by 3 comes out to be x equals 10. And that was example number 5, the last one in our notes. Thanks for watching the video and let us know if you have any questions.